Hi, welcome to this lesson on calculus, cubic polynomials. So what is a cubic polynomial? Essentially, it is an algebraic expression of the third degree and can be represented mathematically by the following expression. A times x cubed plus b times x squared plus c times x plus d, where a cannot be 0, otherwise we eliminate that cube term there that makes it a cubic polynomial. And your b, c, and d are just any real numbers, the coefficients. D is the constant number. So just as we investigated the properties of the quadratic polynomial, namely ax squared plus bx plus c, we have similar properties that we can explore for the cubic polynomial. So we will learn the following skills when it comes to cubic polynomials. We'll learn how to factorize expressions like this, which is called the general form, and we'll be able to factorize it into the factorized form, where it'll be a times x minus x1, x minus x2, x minus x3, and x1, x2, and x3 are what we're going to call the roots of that polynomial. We'll learn how to solve the equation ax cubed plus bx squared plus cx plus d equals 0. That'll give us the intercepts on the x-axis. We will learn how to sketch the function f of x equals the cubic expression there. So that is essentially the reason for understanding cubic polynomials and what we'll need from them in order to do some more examples. So it's important to understand the structure and terminology of a cubic polynomial, as we'll encounter many different cubic polynomial expressions. So here's a few examples of some cubic polynomials. 2x cubed plus x squared minus 3x plus 5. Now this is a cubic polynomial. Okay, the leading coefficient is 2, which is in front of your x cubed term. Essentially, the leading coefficient is the coefficient of the highest power, which in this case is always the cube. 2, and the constant term is 5 here. The coefficients of x squared is positive 1, and the coefficients of x is negative 3. And in total, there are 1, 2, 3, 4 terms. Remember, terms in an algebraic expression are always separated by plus and minus signs. Let's have a look at this one. Negative half x cubed plus 2x squared plus 5x minus 7. Again, this is a cubic polynomial. But the leading coefficient is negative a half. The constant term is negative 7. The coefficient of x squared is positive 2. The coefficient of x is positive 5. And again, there are 4 terms in that expression. What about this one? 3x cubed plus 7x squared plus 11. This is still a cubic polynomial. The leading coefficient is 3 for x cubed. The constant term is 11. The coefficient for x squared is positive 7. But where's the x term? Well, you can think of the x term as plus 0x, because 0 times anything is 0. So the coefficient of x is 0, which is still a real number. But there are a total of 3 terms now in this cubic polynomial. What about this one here? Negative 4x cubed plus 3x minus 10. Again, it's a cubic polynomial with the leading coefficient being negative 4. The coefficient, or the constant term, is negative 10. And the coefficient of x is positive 3, whilst the coefficient of x squared is 0. Okay, and again, there are 3 terms in this cubic polynomial. Lastly, let's have a look at this one. 2x cubed plus 1. In this one, the leading coefficient is 2. The constant term is 1, but now the x squared and x terms both have coefficients of 0. So this is going to be 0 plus 0x squared plus 0 times x. And in this case, there are only 2 terms in that cubic polynomial. Here are a few examples that are not cubic polynomials. So it's important to differentiate between what is and what isn't a cubic polynomial. In this expression, although we have a leading coefficient of 4 for x cubed and the constant term is 8, we can also see there's a coefficient of 2 for x squared, coefficient of negative 5 for x, but then there's an extra term here, negative 3 over x. Now that term makes that entire expression a non-polynomial, because one of the important characteristics of a polynomial is that all variable terms, so the x cubed, the x squared, the x, they must all have natural number powers. So that's x to the power 1, x to the power 2, x to the power 3. But we can rewrite negative 3 over x as negative 3 times 1 over x, right? Because that's negative 3 over 1 essentially, times 1 over x. But this 1 over x, if I use my exponential laws, remember that's x to the power 1. If I bring that power up, it becomes negative, so negative 1. But that exponent there in this entire power is -1, and we can't have negative exponents in those powers for a polynomial expression. Therefore, this is not a cubic polynomial. Okay, even though it's got a cubed term, it's not a cubic polynomial. What about this one here? -5x cubed, that's the leading coefficient of x cubed. We have 3x squared, so the coefficient is 3, plus 11 root x, not x anymore, but root x, and -3. Well, that 11 root x is a problem because square root of x can be written as x to the power of half. Because remember, there's a floating 1 there as an exponent, and the square root means the power of 2. And by your exponent laws, that is x to the power of 1 divided by this number here, so x to the half. And again, we must only have natural number exponents for our powers. So you can't have any fractional exponents in the polynomial either. So therefore, this is not a cubic polynomial. Alright, so that's the difference between cubics and non-cubics. So it's important to understand the structure and the terminology of what a cubic polynomial is for later on when we discuss some more advanced topics relating to cubic expressions. Okay, I'll see you in the next one.